Hello everyone, welcome back to my channel. We are going to finish up our last video about BGP, iBGP, eBGP configuration with IP version 6. In the last video, we configured eBGP between router 1, router 2, from loopback 1 to loopback 2, and within autonomous system 234, we configured iBGP between router 2 and router 3 over a physical subinterface, a different VLAN, and also we are going to configure, finish up the configuration, the basic configuration between R3 and R4, and bring up the iBGP between the two, so we will have a chain of BGP neighbors from R4 all the way to R1. So we have some objectives here that we are going to meet. The last two objectives is that in case of need of IGP with an AS, only OSPF version 3 must be used. And in case of need of IGP, only a static route must be used between ASs. So with an AS autonomous system 234, we are already running OSPF between R2 and R3. Now on R3, I'm going to show you the configuration. Show run section BGP. So as you can see here, I have the configuration for the neighbor of 2002 column 2, which is the loopback for R2, right? So if I do show IP version 6 route, I can show you that I have a OSPF route. Specifically, it educates my router, this route, how to get to this IP version 6 IP address via OSPF, right? So we have met all the requirements for having the BGP neighbor, working between two iBGP neighbors. So what are the requirements? If you remember, the first one is that we have to use update source loopback. We have to change the source IP address inside the packet to the loopback that we are going to bring up the neighbor with, right? And the other requirement is that we should have IP connectivity and IP route connectivity to the neighbor loopback address. It can be any IGP. It can be done by utilizing any IGP or a static route. In this case, based on our objective, because we are using, we are going to have this IP connectivity within the autonomous system, then we are using OSPF version 6. Okay, so here what we are going to do. I'm sorry. What we are going to do on R4, we already have the subinterface configured. We already have IP version 6 addresses assigned. I just want to quickly bring up the iBGP neighbor between R3 and R4. So if I jump over to R4, as you can see, if I do show IP version 6 interface brief, I have my subinterface, the IP address is assigned, loopback is assigned. If I do show run section BGP, I have nothing. Okay, and if I do show run section router, which shows all the running configuration for any routing protocol, so no routing protocol is running. Okay, so on R4, I'm going to first configure the OSPF version 6, so IP version 6 router OSPF1 router ID 4444 log agency changes. Then I'm going to exit show IP interface brief. Should do show IP interface brief. So I'm going to go to configuration mode of my subinterface interface. gig 0/0.34. Here IP version 6 OSPF 1 area. Just a second, I check what area I was using. Show run section. Let me check. Show IP interface brief. Show run. Interface giga 00/23/00.23. Okay, area 0. Area 0. I have it on R4. Right. I should have my OSPF version 3 neighbor up. Let me make sure on R3 I'm running OSPF on my interface, sub-interface 34 as well, which I'm not, so I have to configure it here as well. IP version 6, OSPF 1, area 0. I should have my neighbor up momentarily. Let's check. Show IP version 6, OSPF neighbor. Okay. Two-way. Okay, that's okay. So I have two neighbors, as you can see, from R3 perspective here. I have one neighbor which is R2 and one neighbor which is R4. Right? R2 and R4. So if I jump into R4, if I do show IP version 6, okay, as you can see, my neighbor came up. Show IP version 6 OSPF neighbor. I have one neighbor, full agency. So show IP version 6 OSPF, no, version 6 route. So this is a good news. I'm learning a couple of routes via OSPF. So let's check what routes I'm learning. From R4 perspective, what I'm learning is the loopback IP address of R2, loopback IP address of R3, right? And also the subnet /64 IP version 6 subnet, which is used between sub interfaces for R2 and R3, if I'm not mistaken. Yes, R2 and R3. Okay, so here's good. It shows that I can ping the loopback IP address of IP version of router 3. That's good. So the first requirement, which is the IP connectivity, TCP IP connectivity between the two loopbacks is met. So let's jump into the configuration of the BGP. Let's start from R3, right? So again, show run section BGP, just to make sure that we have a consistent configuration template all over the places. So I just have to go to router BGP, configuration mode, router BGP 234 neighbor. Now the loopback IP address, show IP version 6 interface brief of this guy R4. This is going to be my new neighbor. Right, remote AS 234. Again, update source loopback 1. Cool. Now I will jump into address family IP version 6, and I will put this guy neighbor activate. Okay. So let's see what we have, and show run section BGP. Okay, so this looks good. What I have is that I have configured the neighbor remote AS command for my loopback IP address of R4, and I have activated the address family command. Okay, so R3 is good to go. Let's go to R4 conf the router BGP 234 router ID. Oops. BGP router ID 444 BGP log neighbor changes neighbor. What is the loopback IP address? Show IPv6 interface brief. This guy here, neighbor remote AS 234. Now neighbor loopback. This IP address up the source loopback 1. So I guess we should see the BGP neighbor relationship be up. Let's check. Show IPv6 BGP summary. Show BGP IPv6 summary. Oh, sorry, I didn't activate it. Oh, under the IPv6 address family. Actually, that's a good lesson. So let's check. Should run section BGP. Okay. Now, as you can see, this configuration is not complete. So I just have to jump here and address family IPv6 unicast. Then I copy this guy, neighbor loopback 3, and activate. Let's see what we have here. Okay, so this one looks better. We should see the neighbor to come up. Let's wait a little bit. Let me just check very quick. I can ping the loopback IP address of yes. Okay. So if I do show BGP IPv6 unicast summary, it's idle. Active. Idle. Something is not right. Let's see on R3. What do we have here? Show IPv6. Show run section BGP. IPv6 2002. So let's see if I can ping from R3 the loopback IP address of R4. Aha. Okay. So here's the problem. I forgot to add the loopback IP the loopback IP address of R4 into my OSPF domain. So if I do show IPv6 protocol, as you can see, the only interface that the OSPF is running is my gigabit 00/34. So R4 is not advertising the prefix of that loopback IP address. That's why R3 has no clue how to get to this one. So in order to fix that, I will go to interface, loopback 1, IP version 6 OSPF 1 area 0. This should do the job. Let's see. Yes, as you can see, my neighbor came up. Very good. So if I do show BGP IP version 6 unicast summary, I can see that my neighbor is up. The neighbor autonomous system is 234, the same as mine, which means that it's an iBGP neighbor, and I have learned 0 prefix. Okay, so let's have a quick review what our objectives, that what is missing. So IP version 6 eBGP peer between AS1.1 and AS234. That's done. IP version 6 iBGP peer from R2 to R3. That's okay. R3 to R4, we just did that. All BGP peering must be between loopback 0 to loopback 1 to loopback 1. That's also done. Advertise loopback 2 from R1 in a way that all BGP speakers within AS234 receives it. That's a tricky one. Okay, so let's go to R1 and see if we have that interface at all. Show IP interface brief. Show IP version 6 interface brief. Okay, I have two loopbacks. Loopback 1 and loopback 2. And loopback 2, the address is 1FFFF. Yes, that's correct. I have it. Now I'm going to advertise this guy into the BGP domain, and all my BGP peers should receive that. So let's jump into that. Configuration mode, router, BGP. What was the autonomous system number? 111. Network. Sorry. Okay, address family. IP version 6, unicast. Here, network. Yes, I have to go to address family mode. And here is the network that I am using for loopback 2. Hold on. Do show run interface gig loop. Interface loop 2. Okay, I'm using /64. So here's a point that I should use exactly what I have in my routing table. Network, this guy, and incorrect network has configured. IP versions. Okay, I should delete this one. Yeah, okay, that is the job. Now it has been advertised, supposedly. So let's jump into R2. Where is R2? Here in another autonomous system. And let's check if it has received my advertisement. Show BGP IP version 6 unicast summary. And yes, as you can see, it has received one prefix. So let's check that. Show IP version 6 route. I'm going to check the routing table, BGP, and yes, I have received it. So let's ping that. Loopback IP of, sorry, the IP of loopback 2 behind R1. Okay, that's good. So R2 has received it. Let's check if R3 also has received it. So we will go to R3, show BGP IP version 6 summary, unicast summary. Yes, it has also received it. That's a good sign. So here's the kicker. I'm going to jump into R4 console, and you will see that R4 has not received this prefix. I will explain to you why. So R4, show IP version 6, show BGP, IP version 6, unicast summary, and it's 0. His only neighbor, which is R3, has not advertised the route which he learned from R2. And why is that? Okay, the main reason for that is that here iBGP split horizon rule has kicked in. And what that rule says is that if an iBGP speaker receives a route or advertisement or NLRI from another iBGP neighbor, it's not going to turn around and advertise it to another iBGP neighbor. This mechanism has been uh, has been uh, has been in place in order to prevent layer 3 loops. So how can we solve this? One way to solve this is to have full mesh connectivity between all iBGP speakers. It means that we have to also bring up another iBGP neighbor relationship between R2 and R4, another iBGP peering, which doesn't, our objective doesn't say that, so we cannot do that. And on top of that, in order to do that, we would have to configure another subinterface and another VLAN on switch 2. So we are not going to touch that. So what we are going to do, we are going to use a feature called route reflectors. And our route reflector will be router 3, and our clients will be R2 and R4. And in this case, route reflector is responsible to reflect all iBGP learned routes to another clients, right? So let's do that. I'm going to go to R3 and I'm going to show run section BGP. Okay, so route configuration mode, router BGP 234 neighbor. I'm going to say that my neighbor router 2 is route, sorry, just a second, is hold on. Description for what else? Peer group, remote AS. Hold on, sorry, I forgot the command. Maybe I should go to the address family mode. Family IP version 6 unicast neighbor. And here, yeah, here, route reflector client. By this command, I'm telling router 3 that router 2 is the route reflector client, and you are going to be the route reflector server, right? So as you can see, my BGP neighbor has bounced, right? So I will do the same for router 1 as well. Sorry, for router 4 as well. So do show run section BGP. Okay, so I'm inside address family. Now I'm going to say neighbor IP version 6 address of loopback. Oops. Neighbor, this IP address. Route reflector client. Boom. So my neighbor with R4 should bounce, which happened. Now let's jump into R4 very quick and check if we have received anything here. Show BGP efficiency unit summary, and we haven't received it yet.